Hello everyone, my name is Edison Magalhaes, I am a veterinarian and now I'm a graduate research assistant at Iowa State University. Today I'm going to talk about the whole herd drivers of Wean-to-Finish Mortality project, which is under the umbrella of a bigger research project named Improving Pig Survivability. Improving Pig Survivability is a 5-year project with the goal of reducing overall mortality in the U.S. commercial swine industry, with an interdisciplinary team focused on research and extension from Iowa State University, Kansas State University, and Purdue University. This project is funded by National Pork Board and the Foundation for Food and Agricultural Research. So for more information, please access the website. So now in the modern swine industry, most of the production systems they collect a vast and diverse amount of data related to the production process, such as health, productivity, we have management factors, environmental information. And the problem is that these data streams, they are housed in independent softwares, and they are only being used for some specific needs, meaning that we have a rich amount of data, but with poor information being extracted from it. Therefore, we have here the opportunity to combine this big data available into a single data set based on ongoing and automated models. And having this consolidated data set in the end, containing all the data streams above, would allow the production systems to measure the effect of specific factors on performance and also to make data-driven decisions regularly, based on a collective analysis of the multiple data streams. So the first objective of this project was to develop an automated model using statistical software, so in this case we use SAS software, to capture and merge multiple data streams available within a production system, consolidating everything into a single cohort report, where we would gather in the end all the data available to each weaned cohort, meaning that in the final report, for every closeout, they would have all the retrospective data from service to market allotted on it. The second objective was to basically run a statistical analysis using this final cohort report, where we wanted to measure the association of some specific parameters with wean-to-finish mortality and to forecast wean-to-finish mortality based on multiple variable analysis. So for the purpose of this research, we used around 1,200 closeouts, marked between June 2018 to July 2019, where we gather information from sow farm productivity, sow farm and growing pig health status, infrastructure data, management data, pig flow, and the closeout information of these groups. And these closeouts, they came from single or multiple sow farms, as well as single or commingling nurseries. And the outcome here is the wean-to-finish mortality, like I mentioned. So we can see here the big amount of data, of information from many different areas concerning the production process that are available within the production system. And the objective here was to develop SAS script algorithms to combine all these multiple data streams automatically into a single data set. Therefore, we built an algorithm to consolidate all this retrospective information from service to market to their respective closeouts, generating a final report, a final data set. The second objective was to run a statistical analysis on this final consolidated data set, looking at whether specific parameters were associated with wean-to-finish mortality, as well as forecasting closeout mortality based on combined information. And when we measure which factors were associated with the wean-to-finish mortality of the groups, we could see that sow farm productivity parameters, they were highly associated with downstream wean-to-finish mortality. So for example, here we have total born, farrowing rate, annualized sow death rate. And basically, for example, here in total born, we could see that when total born increased, we could see a lower wean-to-finish mortality downstream. The same thing here for farrowing rate. With a better farrowing rate of the weaned cohorts, they had a lower wean-to-finish mortality. With higher annualized sow death rate, they had a worse performance downstream. So we could see this association of the performance in the sow farm with the downstream wean-to-finish mortality. Thereafter, we saw that sow farm health status parameters, they were also associated with downstream wean-to-finish mortality. So for example, here we have mycoplasma and purge status at weaning in the sow farms, and we saw that weaned cohort from sow farms with unstable status for PRRS and for mycoplasma at the weaning event, they had the highest wean-to-finish mortality downstream. And so far we have focused on measuring the effect of specific parameters on wean-to-finish mortality, but in order to forecast the overall mortality of the groups, we have to do a multiple variable analysis. So in this right chart here, we have all the variables that we measured in the previous step, and the ones in green are the variables that we chose to be part of our multiple variable model based on the eligibility criteria. And we conducted a multiple regression analysis and later a k-fold cross-validation. And basically what this analysis does is to predict the overall mortality of the groups and compare the predicted mortality rate to the actual mortality rate of the groups. And in this case, the predictive power of our model was close to 71.2%. So in summary, what this study proved is the concept that this automated model can be valuable to the production system because it allows the aggregation and consolidation of all the data streams that they are already recording into a single cohort report. So it's important to provide the ability to each production system to aggregate the whole herd data routinely and provide a collective analysis on KPIs. So they can measure, for example, sow farm productivity, disease status, pig flow, and environmental factors, use their own data. So what does this mean and how can producers use this information? So we saw that, for example, this research indicated that sow farm health and productivity, they are a good proxy of downstream performance. We can forecast downstream wean-to-finish mortality of some weaned groups by collecting information of these cohorts in the pre-weaning phase and predicting what it will be their mortality rate throughout the growing phase. Another application is that with this model, we have the ability, for example, to measure some specific products, interventions, vaccines, or management factors. As soon as the production system is recording when, where, and in which group they are using that protocol, we can include that in the model. And we can also do the same analysis, but with different outcomes. For example, with average yield gain, feed conversion, the percentage of yield selected, all along with cost analysis. And this is something that we are working on right now. And lastly, we can include precision livestock farming technologies, for example, as soon as they are being more implemented in the swine industry, because they provide reports on a weekly or daily basis, and it's just a matter of including in the model. And as we can see here, our final idea is to provide a near real-time model to consolidate all the data collected throughout the production process and to analyze it in a way that help producers to make these whole herd data-driven decisions with their own data. So with that, I would like to thank SciSelect Farms and Barry Gingelheim for all the support in this research and the Improving Pig Survivability project. And lastly, I would like to thank my colleagues at the Field Epi team at Iowa State University, especially my advisor, Dr. Daniel Linhares. Thanks for watching and feel free to reach me if you have any questions.